you for the confirmation. So let's get continued forward. So we'll start from where we have stopped from, and then so the next topic is about applications. Now, when we are talking about applications, we will look into basics of what do you mean by message versus event, which one should I use when, what messaging solutions do we have, design an event solution. This is where we will talk about the differences between event hub and event grid. Automation, which is where we will talk about the configuration tool, application lifecycle. So how do I manage an application lifecycle? These are the points which we will cover in this afternoon's first session. Okay, after that we will look into the integration part real quick, and then finally we also have a little bit of monitoring to be covered for today. So that tomorrow we can only do networking and then give more time for discussions about the exam, vouchers, and the rest of the stuff. Okay, so let's go back here. What you see on screen here is a quick introduction to messages versus events. So these days, two things is what you will continuously hear. One, people talk about something called big data. And two, people are talking about modernizing your applications. This is where microservices architecture comes into picture. That's a nice one. Yeah. So we're talking about how we are modernizing. So when we say modern, we're talking about transformation of your applications from traditional 3-tier architecture to microservices architecture, monolithic to microservices. What do you mean by microservices? The term microservices generally talks about how your applications are divided into smaller decentralized services, so that each of these services can separately run, can separately be troubleshooted, or can separately be managed. So when your application is being divided into multiple smaller individual services, how are they communicating? So this is where we are saying we rely on APIs or we rely on asynchronous messages / events. So it is a developer's challenge to design an application which achieves to establish communication effectively so that it can help integrate with other service offerings and improve its availability. That's why I've written resiliency. So the question is, what is my job? Design an application, monitoring, and messaging accordingly. So when we are talking about communication between these decentralized services, design your app, whether you're going to with API. So if it is API, we will bring in API management tool, or if it is messages or events, you define it. So this is where we will stop for 10 seconds and I'll quickly check with you if you guys are following me.
Hi.
Yes, Vijay.
I'm not from software background. I just want to know what is monolithic.
Okay. Any structure, for example, a standard 3-tier application can be considered as a monolith. So why we say monolith is your front end is tightly integrated with your back end, which is tightly integrated with your database. sorry, middleware. I have written front end, middleware, and the back end, which is basically your database.
Yeah.
So the reason why we call this monolith architecture is because all these components are tightly interconnected. If you want to do maintenance on database, your front end should also go down. Isn't that what you do?
That's good.
You will do something called maintenance for the whole application. You don't do maintenance just for database. But hey, wait a minute. When I talk about this database in microservices architecture, it is not one machine or it's not two machines, right? You have multiple containers running. So when I want to bring down one database instance, the others are running still. When I want to upgrade, I can perform roll-up upgrades. Does that make sense? So basically, we are giving you more flexibility with microservices. So if I go to my browser here and then search monolithic versus microservices, I just go here for the first website. And then if I click on images, that's what you will see. Rather than having one standard rock, it will be multiple stones together. That's another easy way to put it. You pick any diagram, it clearly shows you that. Does it make sense?
Yeah, understood.
Okay, I'll just give you this one here. I mean, it can't be transformed in a day, okay? Just moving an application from monolithic to microservice architecture itself is a time-consuming task. And then first thing to understand is, does your application support microservice architecture? So advantages of monolithic application versus microservices. I'll just share this third-party link with you. So wherein you can see, I've just highlighted on the high availability part, and then I've talked about easier management part, right? Maintenance. But there are many reasons why one would want to choose microservices. Example, scaling also becomes easy in microservices architecture. Okay, so I'll just add that third-party link here as well to get more details about monolith versus microservices architecture. Give me a thumbs up if you're following me so far, people. Okay. Now, what is a message versus an event? Let's look into that. Let's pause here and let's cover what we see on screen. A message is raw data. A message is always produced by one component and it is consumed by another component. Whenever we are talking about messages expects the receiver to do some kind of processing upon delivery. Give me an example of it. Where can I use messages? Where can I use events? Before we talk about that example, let's talk about events. Events, when compared to messages, are lightweight. Events are mainly used for broadcasting purposes. Events are sent by a publisher to all receivers, which means subscribers. Sent to multiple receivers or sent to none. Events do not expect any kind of action to be taken. For example, I'm again talking about Lazada, which is the e-commerce website. When I place an order, I keep getting notifications from Lazada saying that, hey, reseller has packed your item. Your item has been shipped for delivery. Your item is on the way to airport. Cleared the custom. Received on destination's airport. Cleared customs. Because Singapore is such a small country, everything has to come from outside. So customs is normal here, right? Once you receive that message, cleared customs, the item is in sorting center and the item is out for delivery. So it is a different status. In every stage, I get notified. That's an event. And then I don't have to do anything as an end customer. Whereas in messages, it's a different complete story altogether. Same Lazada example. Let's say there was a sale, right? Recent sale, 7/7 sale. Nowadays, it's every month some kind of sale that pops up. So 7/7 sale. So what happens during the 7/7 sale? The number of people that log into this website to place order increases because most of the stuff is on good price. At least you'll get a minimum discount of about $6 to $10, right? This is like minimum what they're offering these days. So on a minimum purchase amount, that's a different story. So what I'm trying to highlight here is when thousands of users are logging into this website, the front end is busy. Now the question is your backend able to process those requests at the same speed? May not be. So when it doesn't, what we're going to do is we're going to get something called queues in between. So queues allows you to implement backlog of work so that you can do the processing at your own speed. So what am I trying to sell here? Hey, messages are for communication between your application components. Example, your front end and the back end. Events are to notify somebody about an action that is being taken. So if you look at the example, a user using a SoundCloud application who uploads a song, the moment you upload a song, a message is sent to a web API component of that particular application. So what will this component do? It's going to scan really quick whether that song that has been uploaded is correct or not, right? And then it's going to generate a new alert saying that a new song is added. Meanwhile, it will also go ahead and update the database. This alert is nothing but an event. All subscribers get notified. Yeah, SQS and SNS, that's correct. So for queuing, we have queue service as well as we have something called system queue. So we will talk about both. So, but before we jump into that, so far so good. Just give me a thumbs up if you're following me to understand the difference between messages and events. Thanks, Vijay. So, few points about messages. Like I said earlier, messages come into play whenever we're talking about communication between your application components. For example, the front end and the back end. Messages by default are of 64 KB in size. Messages can live in queue by default for 7 days. Whenever we talk about queues, we have two solutions. One, we have storage queues and then service bus. Now, which one should I choose? It depends on what you need. For example, the size of a message is limited to 64 KB in storage queues, but it can go up to 1 MB in service bus. Sorry, not 1 MB, 256 MB if I'm not wrong. And then storage queues are always one-to-one communication, which means one front end talking to one back end, right? But what if I have one-to-many communication that needs to be established? So again, service bus comes into play. There are many other features as such. For example, there is no first in, first out rule guaranteed in storage queues, but it is guaranteed in service bus. All these details are captured in this theory article where we talk about storage queues versus service bus. Comparing the services. This is a simple example. See here. Just capture a bit of the screenshot here. And then I will paste it. Yeah. Okay. And then I'll also add the KV article. It's already there. This is the KV article. So this article, if you scroll down, you will see the sizes as well, which I've just mentioned about. See here? At some place it will talk about the message sizes. Yep, 64 KB, 100 MB. My bad, I said 256, but it is 100 MB. Okay, and then it also talks about the number of maximum queues that you can have. For few, your service bus is good. For example, service bus is for any application that's looking for many features integrated into it. But the size of the service bus queue is limited to 80 GB. Whereas here in storage queues, you can go up to 500 terabytes. But again, it completely depends on what feature sets do you need. So all additional information and comparison table is here. You guys can look into it to understand which one fits best with respect to cost and with respect to feature sets. So now that we understand about events and messages, what Microsoft have here is different solution offerings. Hey, if I need to forward events between multiple different applications, right? Front end, back end, sorry, one application app one to another application app two, or from a virtual machine to a backend storage account, I go with Event Grid. So Event Grid is the routing component. Okay, Event Grid is the routing component. So that's what I've written. Event distribution is what this solution do. So when will this come handy? Hey, you can bring Event Grid as a mediator to respond to any action changes. So yeah, react to a status change. Event Hub is basically a place, it's a repository where you can dump all your events. So you can create pipelines, you can stream these events, you can collect data through something like telemetry and distributed data streaming, right? And then analyze, and then notify when something is really not working as expected. What people do is they collect the information at Event Hub and use solutions like Synapse in order to analyze the data that you have collected and then respond accordingly. Service bus is basically to play with your messages. Most of the applications, wherever you see order processing and financial transactions like OLTP applications, you would see service bus, primarily dealing with application communication. So I'm just going to pause here for 10 seconds. I'm going to allow you to digest the information which you see on screen, and then we go forward. So first thing, what we did, we started with discussions like, hey, what is monolithic versus microservices? Then we said how microservices establish the communication. Then we said APIs versus messages and events. Then after that, we discussed API versus messages and events. Then we said, what is a message? What is an event? Message expects action. Event basically the notification, no action required. And then we said messages. We have storage queues versus system bus, sorry, service bus. And then for events, we have event hub versus event grid. So any questions so far? I'm just going to place this pointers here in the chat box. Any questions before we go forward? All good so far, people? So let's go forward. What we have is monitoring section. We will come back to the monitoring. There are a few important points which we can find in the deck. So let's complete the deck for applications. Take a small 10 minutes break, come back, start with monitoring, take a small 10 minutes break, and finally complete your integration options for storage. Okay. So, where were we? Yeah. This is what we discussed. In which scenario I would use message, in which scenario I would use event. Event, lightweight, includes publisher and subscriber, mainly used for broadcasting purposes. Ephemeral means the communication might not be handled by receiver if none is currently subscribing, which means it can send it to all subscribers or it can send it to nobody. So no action required. That's the point that we have discussed. Messages are always been about raw data produced by one that will be consumed by another. Contains the data itself, not just reference to the data. Used where the distributed application requires a guarantee that the communication will be processed, which means some kind of action is required for your messages. There are two types of messaging solutions. The first one is queue storage, which is nothing but your storage queues. What does it do? Hey, it creates a backlog of work so that you can process it asynchronously. For example, when your front end is bombarded with new requests, is your back end capable of processing the request at the same speed? If not, then you create your queues. This is what we say. And like we discussed, queues are holding your messages of 64 KB by default in size. With storage queues, you can access the messages anywhere, anytime using HTTP and HTTPS. Contains millions of messages. If you remember, the max size you can go up to is 500 terabyte. Then we have talked about service bus. If you remember, one of the points that we mentioned for service bus in the whiteboard is one-to-many communication, which means the sender will be many, whereas the receivers are many. So the sender will be one, the receivers are many. So we call this as topics. So like the bus queues, but with multiple subscribers. When a message is sent to a topic, multiple components can be triggered to perform a particular task. Service bus by default is one sender, one receiver, but it also supports topics. So service bus holds messages until the target is ready. And then, like I said, there's no expiry for the message in service bus, whereas compared to your storage queues where the message will expire after 7 days. See here, comparison. This table we already saw. 80 GB versus 500 terabyte. And then we are talking about simple queue to organize messages. A first in, first out guaranteed is available to you. So can exceed 80 GB, which means max 500 terabyte. Yeah, max is 80 GB. My bad. At most once delivery, which means I can collect multiple messages and deliver it at once. That feature is not available with queue storage. Can group messages into transactions, provide role-based access model to the queues, publish and consume batches of messages. All these advanced features are available to you only with Service Bus. Topics, multiple receivers, multiple destinations for a single message. SLA is dependent on the storage tier for queue storage. If you remember, we did talk about standard versus premium. That's what we are talking about, because to create a queue storage, step one is to configure your storage accounts. Whereas for service bus queues, we are saying 99.9, and for topics, we are giving 99.99% of SLA. Events. Like we said earlier, hey, we have two solutions for managing your events. Now, Event Hub is a solution where I've told you it's basically a dump yard for all your events. What do you mean by dump yard for all your events? Hey, events are generated at multiple different layers in your data centers. Now, there are certain applications that produce massive amount of events, right? Excuse me. So this massive amount of data is what we refer as big data. And then big data we require extensive infrastructure. For example, think about Rolls-Royce aircraft engines, right? The engines that Rolls-Royce manufacture have hundreds of sensors. And all these sensors create some kind of events. So when I want to collect events from all these sensors and manage them centrally, Event Hub comes into play. Okay. So what does Event Hub do? It's a fully managed real-time data ingestion service, which means Event Hub acts like the dump yard where all your sensors can forward their events. So event producers here is basically your Rolls-Royce aircraft engine. Okay. So what will this guy do? Event Hub supports real-time data ingestion, which means it's gonna consume the data that you are sending it to it, and then it allows you to detect anomalies in the data, okay, by using live dashboards. It allows you to create analytic pipelines such as click streams or to archive your data. It allows you to figure out transaction processing with real-time analysis, right? So this diagram shows how event hubs could be used in an artifact, right? So a basic thing what we're trying to highlight here is ingest the data, store the data in Azure blobs, bring a data analytical solution like Synapse or Azure Stream, then use dashboards like Power BI. So that's exactly what people would do whenever we are talking about large enterprise environments. So the main condition here that I want you to remember here is, hey, scenarios wherever you need application logging, live dashboards, archiving data, transaction processing, go with Azure Events. Give me a thumbs up if you're following me so far. Okay, thanks, Rishi. Then we have event grid. If you remember, I've told you event grid is the routing component. So it's a routing service which connects a source to an event handler. For example, in a situation where your mobile application wants to notify something through event, I can send this event to the event grid, which then forwards it to the respective handler. Example, uploading a song that generates an event. Event grid can forward it to an Azure function. An Azure function is a piece of code which then can check if the song upload is of right size. This was the example which we saw. So I'm just telling you where your event grid can fit in. So it basically comes into play whenever you want to react to an action, right? Use filters to route and multicast events. Use paper event pricing model. So this is the same example. So event.
Why is it not a messaging use case? Because like messages are usually meant for a specific destination, right?
No, messages has always been within an application, but here the destination can be anything. For example, it can be a webhook, which means a website, right? It could be your queue storage. It could be your hybrid connections. It could be your event hub itself. It can be an IoT hub. So if you see here, whatever you see on the left can also be your handler as well.
Yeah. Okay.
So this one here talks about the steps which we have talked about. Let's say you have a front-end website, right? So let's say this is www.shareyourpics.com. Just a website where you can upload your photos like a Google album and then share it with anybody for free of cost. So when I do this, what am I doing? Hey, step one, I'm uploading my files. So behind the screen, I'm uploading to a storage account. Okay, great. Whatever files that you have uploaded, I need to make sure that they comply with the rules that I've set. For example, hey, I don't want you to upload anything which is of adult content. Just an example, right? So I don't want you to upload pictures of this quality or this size. So whatever rules that you have defined. So step number one, you are going to the website, you are uploading it. Step number two, an event gets generated saying that, hey, this particular file is uploaded. Step number three, your event grid, which acts like a routing component, tells the Azure function app saying that, hey, there is a new file upload. Please check whether the file is of our compliance, if it meets our compliance requirements, if it is of our requirement. And then Azure function will then go to the storage, retrieve that file, check if everything is as expected. And if everything is as expected, primarily the size, the format, and then the regions, it will then go ahead and update the database saying that, hey, on this particular date, this particular user, this particular file with this name has been uploaded. So all these things come into play. So Event Grid is mainly used for reactive programming, which means take action when something has happened. Event Hub helps to create big data pipelines. Service Bus is our high-value enterprise messaging service. So whenever we talk about messages, your solution is limited to queues or service bus. When to use? Event Grid whenever you have a status change. Event Hubs, any telemetry and distributed data streaming that you want to analyze. Service Bus, order processing and financial transactions. Everybody clear so far? Just give me a thumbs up if you're following me, people. Now, most of the time, in some enterprises, what I've seen is people use Event Hubs alongside Apache Kafka. So if you have used Apache Kafka, it's an open source distributed event streaming platform. It does what Event Hub does. But the challenge here is setting up the Kafka cluster itself. Though it is built to real-time streaming data pipelines and real-time streaming applications, setting up Kafka itself is a challenging task, right? But whereas when we talk about Event Hub, it's a platform as a service. It becomes really easy for me to get started. And I can consider Kafka as my source, and I can get my own streamlines of data from Kafka as well. So you don't need to configure, set up, and manage your own Kafka and Zookeeper clusters, or use some Kafka as a service offering not native to Azure, because all those capabilities and more are available to you with Event Hubs. Then we have something called IoT Hub. What is IoT Hub? Think about your, what do they call it? Apple Watches, for example, right? Or Fitbit, anything which you use for tracking your health status, right? Your health trackers. So what I'm trying to highlight here is when multiple people are using, what are these devices doing? What are these devices doing? They are collecting data. And then what are they doing? They are sending this data to a central repository. And then they are analyzing it. And then they are publishing it, dashboard. So this is where the Apple Health app comes into play. So why am I talking about this? Hey, whenever I'm talking about any IoT device, I can consider this to be an IoT device. Okay, another example of an IoT device can be your self-driving car, right? All these things play an important role because self-driving car has multiple sensors around it, and each sensor is collecting a lot of information that it sees on the roads, right? The driving behavior of the other drivers on the road, right? So when it's collecting this information, if I need a central hub so that I can put all this information together, that's where your IoT hub comes into play. So all your IoT devices can centrally have this information stored in the IoT hub and then allow the IoT application to work forward. So basically, why should I go for it? Because it is a managed service and it runs in the cloud, acts as a central messaging hub for communication between your IoT application and all these IoT devices. You can connect millions of devices and their backend solutions reliably and securely. Few other times, people use IoT Hub for telemetry services, geographic coverage, device support, tracking purposes, and managing devices. There is a company called Maersk. I'm sure you might have heard this name before. During COVID time, they played a very important role. So the vaccinations were to be shipped from one country to another country, and like you all know, the shipments were mostly by water or by air, right? So Maersk was one of those companies which used to offer those containers with cooling units so that the medicine is not expired or the medicine doesn't get affected by the temperatures, right? So using IoT app, they were able to get data about those cooling sensors, like how cold the storage unit was, how cold the container was, how much time is it going to take, and then they were used to capture this information live, right? So this is one of the examples. Another example is one of the major e-commerce website also uses IoT hub, where in a large retail environment, um, whenever the shelves have items put and whenever the shelves are emptied, which means the items are being removed, the sensors in the shelves will monitor the products for replenishment, which means the aisles in the stores will have cameras to monitor flow of people taking items off shelves. All that comes into play. So automatically it tells you how much inventory do you have, how much is left, which one is being sold at the faster pace. All these are few examples where your IoT hub can come handy. Just give me a thumbs up if you're following me, guys. So for applications, if you remember, we did talk about front end and back end. So whenever we're talking about automation, the first thing which we are recommending is a cache. So add a quick cache layer to the application architecture to handle thousands of simultaneous users with near instant speed. We did talk about this yesterday when we were talking about database solutions. Okay, caching is more effective when you need to repeatedly read the same data, right? Any frequently accessed information. So Redis cache is the go-to solution. Is it derived from open source Redis? Yeah. So basically, Azure Cache for Redis is available to you in two versions. So we call it as OSS Redis, and then the other one is called as Redis for Enterprise. The Redis open source is what OSS Redis is, and the commercial product from Redis Labs is Redis Enterprise, which is also a managed service. So Azure Cache for Redis provides secure and dedicated Redis server instances and full Redis API compatibility, right? So you can use Azure Cache for Redis for multiple purposes. Example, a session store. Example, data distribution. Example, content cache, right? Why should I go with it? Number one, performance, which is where we are talking about superior throughput. So it can handle millions of requests per second with down to sub-millisecond latency. So that's the main thing. And then resiliency, which is where the factor high availability comes into picture. So it responds automatically to both anticipated and unanticipated changes in future, depending upon the demand. It's a fully managed solution, which means it's offered to you as platform as a service often. And key scenarios include data cache, content cache, session store, job investment viewing, and distributed transactions. Then I told you at the beginning, if you are moving your application architecture from monolithic to microservices, one of the ways to establish communication between these microservices is to go with API. So what is this APIM, which is nothing but API management solution? So what we are trying to highlight here is, hey, it is a single gateway, which means it's a platform as a service that helps you publish, secure, maintain, and analyze. Publish, secure, maintain, analyze. What? All your company's APIs. Now keep in mind, your APIM is not the place where you would deploy your APIs. Your APIM just acts like a front door for all your organization's API, which are then routed to the respective server where your actual API is deployed. Now, that's why I keep repeating myself. Your APIM, which means the gateway component, doesn't host your actual APIs. They need to be routed where they were originally deployed. Instead, your APIM acts just like a facade. right? A front door for your APIs. In this way, you can decouple the management of your APIs by going to individual servers, and then lets you define policies and other management options with which you can leverage on the management part. For example, the number of APIs, the rate of API changes, for example, API administration load, right? Managing standardized API specs, protecting those APIs. All these are the things which we do. And then application lifecycle, this is where we have something called infrastructure as a code. We did discuss this when we were talking about blueprints. So what we have here is an introduction to something called bicep template versus JSON template. So the question is, what kind of tools are we using to automate your environment? So what Microsoft is offering you is something called bicep. So what is this bicep? So bicep is domain specific language, which means, hey, if you're not somebody who understands JSON, okay, don't worry. I'm going to give you an environment, a tool which allows you to automate with domain specific language, which means it becomes really easy for you to configure your templates. Behind the screen, this DSL is still converted into JSON. Remember that, okay? So bicep is a DSL, which means domain specific language, but deploying your Azure resources declaratively. Habib, what if I need a solution that allows me to orchestrate not just in Azure, but also in on-premise and other cloud platforms, for example, AWS and VMware's vSphere environment, right? So that's where we have solutions like Terraform coming into picture. So most of the time, large enterprise environments would have automation tools like Ansible, Chef, Puppet, or your ARM templates where you can bring in your blueprints, right? So what we are trying to highlight here is this guy, Bicep, takes a single reachability approach wherein it allows you to adopt agile development methods and then deploy your infrastructure in a more reliable state. What I'm going to do is I'm just going to pause here for a quick minute, and then I'm going to bring your attention to an article where they talk about bicep versus Terraform. So the main reason why I do that is, hey, this one is primarily for those who are not Java ready. See here, comparing Terraform and Bicep, article from Microsoft. Let me see that term. See here, to achieve scale, DevOps teams are always looking at ways to quickly deploy code with trusted and repeatable process. When it comes to the cloud infrastructure, the process is increasingly accomplished with infrastructure as a code. There are a range of tools available to perform this. Example, Terraform is an example of the former, while Bicep is designed to handle Azure-related tasks, which means Bicep is limited to Azure platform only. Both Terraform and Bicep are desired state configurations, which makes it easy to manage IT and development infrastructure code. Terraform stores the state about your managed infrastructure and configuration. Terraform uses this information to map to real-world resources to your configuration, track metadata, and improve performance. Like Terraform, Bicep is declarative and goal-seeking. However, Bicep does not store state. Instead, Bicep relies on incremental deployment. That's a different change. The other important point that I wanted to tell was how easy it is to get started with Bicep than Terraform. So another important point, Bicep is Azure specific, not designed to work with other cloud services. If your goal is to automate deployments in the following environments, then Terraform is the better option. Microsoft itself clearly tells that, right? So processing is faster is what we are saying with Bicep. There is one point. Yeah. bicep makes it easy. Again, this is the point. So let me just give this article to you. I want everybody to open that article, and then this is the article which we have. Multi-cloud, Azure only. And then what is this app configuration? This is something like host profiles if you have worked on VMware's infrastructure. What does it do? Hey, it's going to capture the settings of your applications and manage those settings, application settings, centrally. So what is the benefit? It provides you an opportunity to deploy. So tomorrow when you want to replicate these settings, all you have to do is just apply this profile, right? So use app configurations to store all the settings of your application and secure their access in one place. That's what it does. So it gives you flexible key representation mappings, point-in-time replay of settings. You can do a quick comparison between two setting configurations, enhance security through Azure Managed Identities and encryption. So all these are the benefits that you get with app configuration. So you can also use taggings with labels, right? Point-in-time replay of settings. Then we are talking about native integration with any popular application frameworks is available to you there. That was the last one. And this is where we're going to pause our discussions on applications. So we started with a long list, right? We started with messages versus events. Then we went into your storage queues versus service bus, event grid versus event hub. Then we have talked about IoT hub. Then we have looked into automation, which is where we have talked about Redis for cache. And then under automation, we also talked about Azure Bicep, which was domain-specific language for deploying your Azure resources only. Then after that, we have talked about your application configuration manager. So any questions, guys? Again, these are all only high-level overviews. We didn't go deeper here because whether you will integrate this or not depends completely on your application. And any course which starts with DP, like DP 200, DP 300, DP 100 is the backend related courses and data integration courses, which means these courses primarily concentrate on your data, right? And then AZ-200 is where you will bring all these application architects. So attend these trainings to get more insights into how these all solutions are coming together. You can work on these solutions hands-on so that you can decide yourself whether you want to integrate these solutions or not. Okay. If you're good so far, so give me a thumbs up. So we are gonna talk about your login once we come back from a short break. I'll give you a 15 minutes break, and then after this I will give you another 15 minutes break. So we have another 25 minutes dedicated for your login. This is a small one. Just check. See here, just 20 slides. If you remove all those headers and everything, it will be 15 only. Let me bring up the timer.